Hi, in this video, we are talking about section 3.2, which is combinations. And this is really just setting us up to be able to do some fancy probability in chapter 4. So basically all of chapter 3 is just getting us ready for chapter 4. All right, before we get to combinations, we want to talk about the fundamental counting principle. And so it says if a first event has A possible outcomes and a second event has B possible outcomes, then the total number of different outcomes is A times B. If there's a third event, C outcomes, you just do times C, and you just keep multiplying until we know all of the possible outcomes. Okay, so if we have 6 different events being ordered, so let's just think about the numbers 1 through 6. So if we want to write the numbers 1 through 6 in all the different possible ways. So for example, we have 1, 2, 3, 4, 5, 6. We have 1, 3, 2, 4, 5, 6. We have 1, 4, 2, 3, 5, 6. You see what I'm saying? Like just mix all the numbers up, all the possible ways. It's going to take a long time to just say them all, but there is a way we can calculate this. So if I want a 6-digit number, nice straight lines here, 4, 5, 6. Here's my 6-digit number. I have any of the numbers could be first. So there's 6 possibilities for the first number. But once I use up that number, say I used up the number 1, hide it over here. If I use up that number, I only have 5 other numbers to choose from. So the next spot, there's only 5 numbers available. And then after that, there's only 4 numbers available. And then after, think of maybe, I don't know, is this making sense? I haven't taught this in person yet, so I can't see your faces. But think about this as like people in a group. There's 6 people in the group. Who's going to sit in the first seat? Once that person sits in the first seat, they're done. They're already seated. So now you have 5 other people. Who's going to sit in the second seat? You grab someone, now they're done. There's only 4 other people. And so, and as each person sits down, there's less and less people standing. And by the time you get to the last chair, there's only 1 person left over. So the way we calculate this is to multiply times between all of these, because there's 6 spots. So we're going to do 6 times 5 times 4 times 3 times 2 times 1 on our trusty calculator. So let's see, we get 6 times 5 times 4 times 3 times 2 times 1. 720 possibilities. This is why I wasn't going to list them out because there's way too many. There's 720 different ways. You don't have to write different ways, but I just want you to remember what we were actually doing. Okay, try it again. How many different ways can 4 events be ordered? Okay, 4 people are sitting at a table. How many people can sit in the first seat? Once they sit down, how many people can sit in the second seat, and in the third seat, and in the fourth seat? So we have 4 people standing, and someone sits down. Now we have 3, now we have 2, now we have 1, and we are multiplying all this together. And some of you are pretty good at statistics already and probability, and you're like, I know a faster way. Cool. Well, we're going to get to that faster way in just a second. So 4 times 3 times 2 times 1 equals 24. This I could probably list out because there's 24 different ways, but that sounds messy and you all don't need to watch that. Okay, so that was just like people standing up. Once they sat down, they were all used up. They weren't used up, but you know what I mean? Like they're already seated, so they weren't standing anymore. This next one is a little trickier because we have multiple things happening. So it says a local diner offers a daily breakfast special with 1 breakfast sandwich, 1 order of potatoes, and a coffee, and then it gives you the amount of money. Okay, so I'm going to just start. This looks like we need to write something down. So we have our first choice. So wait, we're going to do choice 1. Oh, Lordy, I hit tab and I went back to the last video. Oh, back to the future. Okay, choice 1, and then I'm going to write choice 2. And so that was, and then we have 3 choices, I think. Okay. Choice 3. Sandwich, oh, wait, I'll just write it down. Okay. Choice 1 was the sandwich. Choice 2 was the potatoes. And choice 3 was the coffee. Okay, so unlike before we had one table and we had 4 people standing, someone sits down. Here we have like 3 different tables kind of thing. We have the sandwich table, the potato table, and the coffee table. Okay, I correct myself up, coffee table. Okay, anyways, here we go. Sandwich, potatoes, coffee. So for the sandwiches, how many choices do I have? It says egg only. I'll underline that. Egg only, egg and sausage, or egg and bacon. 3 choices for my breakfast sandwich. How many types of potatoes do we have? We have hash brown, boiled potatoes, okay, or French fries. 3 choices for potatoes. Coffee. How many choices do we have? We have iced and we have hot. 2 choices. So now that we have each item and we know how many choices there are for each item, now I am ready to multiply, because that's what we're doing here. We're finding out how many possible outcomes there are for each choice, and then we are multiplying all those choices together. So I have 3 choices for a sandwich, I have 3 choices for a potato, and 2 choices for coffee. So I go over here and do 3 times 3 times 2, and that equals 18. What are we looking at? 18 ways to make a breakfast special. So there's 18 different combinations of ways that you can make a breakfast special for this $6.50. Okay. Next up, we have the factorial. Look how excited it is. It has an exclamation point. It's the most exciting thing in math because of the exclamation point. And so the factorial of a natural number, it's written n exclamation point, is the product of all the numbers less than or equal to n. And this is kind of messy to understand. So what I'm going to do is I'm going to use this idea of the exclamation point, and I'm going to come back up here because I told you there's a faster way to do it. So this right here equals 6 factorial. Because 6 factorial means you start with 6 and you do 6 times 5 times 4 times 3 times 2 times 1. That's a shorter way to write it, is 6 factorial. This one right here is 4 factorial because it's 4 times 3 times 2 times 1. This is not, part 3 is not a factorial because it's not 3 times 2 times 1. There's a couple 3s, there's a 2, there's no 1. It doesn't follow the pattern. So this one's different. But if you start with the number where the exclamation point is, and you go all the way down in number order, down to get to 1, that is a factorial. Now to do 6 factorial, we already know the answer is 720. I want to show you a faster way to do this on your calculator than what we did, but I need to make it bigger because there's some tiny buttons to see. Okay, so if you look really close at the period right here, you can see there's an exclamation point, very tiny. And so what we're going to do is we are going to type 6. And since it's tiny, it's our alpha. Alpha gets us the tiny ones, just like how the alphabet is up here in tiny letters. So I hit alpha, and then I have exclamation point. We know the answer is 720 from above, and we get 720 again. Try that again with 4. Exclamation point, so I hit alpha, and we get 24. If you have, I didn't bring my other calculators with me to make this video because I love this one so much, I forgot the other ones exist. But if you have the other ones, there's a probability button, PRB, on your calculator, and that will have your exclamation point on it. And if you can't find it, if you were using a different calculator and you can't find it, just let me know. Okay, so what does that give us? Come over here in your spot. Oh, kind of. Okay, what does that give us? here. So it says, suppose a box of chocolates contains 20 unique pieces of chocolate. If you draw one at a time, how many different ways can you draw all the chocolates? We have, I'll come back to it. We'll just continue on this. We have 20 chocolates. So there's 20, take one out. Now there's 19, take another one out. Now there's 18, and so forth. And so we're just going to, this is write your answer in factorial notation right here. So we don't even have to calculate it. And so we're just going to say that this is 20 factorial. And to do that on the computer, you'll just type in an exclamation point, just like you would if you were writing something. But I was going to say that I forgot is this last sentence, we define 0 factorial as 1. So 0 factorial equals 1 because we're going to need it in chapter 4. We need that rule. And so we have it here just in case. I think we actually need it a little bit in this chapter too. Okay, next one, we have 9 things. If we select them, how many different ways can we select all of them? You guessed it, 9 factorial, because it says to write it in factorial notation, so we didn't even have to simplify it any further. Nice. Okay, the reason we went on that little tangent right there is because we are focusing this whole section on combinations. And so before, we just had like 20 chocolates, or we had, I already forgot the first example, we had 6 items on a list. But now we're going to have different kinds of combinations that we can make. And the way we write that is you could see a little n, a big C, and a little r. And I'm pointing this out because if you have a different calculator, when you hit the probability button to find the factorial, you'll also see this button right here. The way you read this is n choose r. That's how it's read. Another way to write this is like with kind of a giant, I'll make it equal sign, kind of like giant parentheses, and it has an N on top, and it, get me out of here, that's ugly. Okay, let me just type it. You have an N on top, and then you have an R on the bottom. It almost looks like a fraction, but it's not. It's just n choose r. I'll show you when it comes up on the calculator, it'll look a little better. But what this means is we have n items total, and we want to choose r of them. So, and I just keep saying n choose r over and over again. So let's just do this whole problem with an actual example. The swimming team has 15 members, so there's 15 people all together, and the coach wants to make teams of 5. So how many different teams of 5 can she make? Now, I'm not asking 15 divided by 5, because I know if you took 15 and you put 5 here, 5 here, 5 here, that equals 3. However, that's one combination because team A, team B, team C are all fixed. Now, what if we mix those people up? Now, what if we mix them up again and we keep mixing them up? What's all the different ways that we can make teams of 5? So we are going to do n choose r. So we have n factorial. Oh, well, let's just look at this problem. N is the total number of numbers. That's always the case in statistics. So there's 15 numbers in this problem, and r is what we are, the number of ways to select. So we are selecting 5. And so I have this problem right here. Now, I'm just going to do this by hand one time. There are really cool calculator ways to do this, which I will do shortly. I just want to show you what it looks like when you do it by hand. So if I have my line, then on the top, I have n factorial. Okay. And then on the bottom, I have r factorial times, oh, that's both of them, n minus r, or 15 minus 5 factorial. And that is another way of saying, what's that equal? Ooh, getting a little out of hand over here. Equals, just simplifying this slightly, we have 15 factorial on top, and then we have 5 factorial times 10 factorial. Okay, what does that mean? oh, this is going to be ugly, but we're going to be able to reduce a bunch of stuff. Now, you can abbreviate this a little bit. I'm going to just, well, actually, I'm going to abbreviate it too. But on the bottom, I have 5 factorial, which is 5 times 4 times 3 times 2 times 1. And then I'm going to multiply that by 10 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times. But I'm just showing you the theory behind this. We're not going to type all this into our calculator. And then on the top, I have 15 factorial. So I have 15 times 14 times 13 times 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1. I put a little dot dot there because I'm starting to see things that are familiar. So what I have here is I have 10 factorial. I have 10 times 9 times 8 times 7 times 6 times 4 times 40, all the way down to 1. And down here, I also have 10 factorial. So by the magic of fractions, we can say reduce. So what we have on the top is, let's see. I'm just going to put my divided by so I can get my fraction already. So I have 15 times 14 times 13 times 12 times 11. And then I have 5 times 4 times 3 times 2 times 1, because all of the 10, 9, 8, 7, 6, all that stuff canceled out. And that's what I was afraid would happen, because I'm going to put this back correctly. Show me the answer. 3003. Okay, cool. That's not that exciting, but that's the answer. So what would be more exciting would be to not have to do that much work to get the answer. Yes, you agree with me. I can see you nodding through the computer. So we are going to use this N choose R button. Again, if you have this calculator, I just worked so hard to put it, and now I'm going to mess it up again. I'm going to show you, it's going to look like this. If you have a graphing calculator at home, I mean like a TI, whatever, it probably looks more like this under the probability member or a menu or a scientific calculator. Just like the factorial, let me know if you can't find it. Okay, so here we want N choose R, 15 choose 5. So this little thing, it took me a while to figure out what it is. But it says paste, and then there's a little picture underneath it. That picture, since it's in black, it's a toolbox. So I'm going to click on it. I don't have to hit anything else because I want the black button right there. And here's my toolbox. And you're going to start off up here, and then you just go down until you get to probability. And then we are doing combinatorics today. So you'll notice the factorial button is down here. If you forget about it being over here on the period, then you can get it off this menu. And then this beautiful N choose K combination, and it tells you right there, it's a combination. Look at this one, permutation. We don't use that word. If you don't use that word, if you don't know what it means, then don't use the button. So it's very easy to see we are using combination button because we're talking about combination. So I'm going to hit OK. And now it gives me my 2 spots. So I had 15 choose 5. And look at that, exact same answer, way faster. Now I'm going to do this again wrong just to see what happens. Oh, that was nice. Did you see that? I hit toolbox and it took me right back here. So when you're in the combination mode, it'll just keep taking you back to that menu. I'm going to say, oh, what if I type it in backwards? What happens? I get 0. It's not, you'll get 0 every time if you type it in backwards. So if you start getting a bunch of zeros, that's your clue that you are doing something upside down. Okay, here we go. Perfect. So this one has a lot of examples here because I just wanted to try this button as many different ways as possible. Okay, so we have a board game. We have 4 tokens. They're choosing 4 out of 10. So how many different ways are there to choose 4? So this is read as 10 choose 4. So if you're using your other button up here, if you're using this button on your calculator, then you would just type in 10 and then this button and 4. But if we're using this calculator over here, I'm going to go to my toolbox. I'm already ready with my combination. 10. Ooh, I hit enter. I didn't like that. Let me hit it down. 10, 4, and I get 210 as my answer. And so this isn't 210 tokens. This is just 210 different ways. We're finding how many combinations, how many different ways are there to make these. So we're always looking at that many different ways. In this example, it would be like 3,003 different teams, different ways to make a team. Teams of 5. Okay, here we have 20 different toppings. So there's 20 total. And we want to make how many different pieces can be each made with 5 toppings each. So there's 20 total, and we want to choose 5. How many do we get? Maybe I just made a lot of these examples because I like this stuff. 20 down, don't hit enter, hit down. 20, choose 5. This is really late for this reminder, but don't forget this is an app you can use on your phone and just do it along with me, or you can just have this split screen like I do, or just toggle back and forth. Ooh, that's a lot of pieces. So we have 15,504 different pieces, or different ways to make a pizza. It's not toppings, it's pizzas that we're making. It's whatever, yeah. Okay. And so finally, or not finally, but here's a couple of trickier ones that I left for the last. So it says, how many ways can you arrange the letters in the word pasture into groups of 3 letters? Now it does not say in words of 3 letters. So we could have, I'm just going to write down a few examples. PAS, AST, STU, URE, just all the different ways. Just put the letters, mix them up, blah, 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 blah. Okay, so even though these are letters, there's still a certain number of letters that we have. So PASTURE, 7 letters total. And we are going to choose, it says 3, 7, choose 3. So it was written a little differently, but it's the same problem. We have 7 total things and we want to choose 3 of them. Okay, so go back to my toolbox. 7, choose 3, and I get 35 different ways. Again, these aren't words, right? Like you can see from the 4 that I wrote, they're not words, but there's just 45 combinations. Okay, there's the last one. So 9 and 10, like I said, they're a little trickier because they don't just put the numbers in order for you. You have to think about them a little bit more. But the last one says a youth group team has 9 girls and 6 boys, and 5 players can be on the court at a time. How many groups of 5 can be made that are all boys? So no girls on this team, all boys. Well, you might think, because there's 15 people altogether, that we start with a 15 total. But we're not looking for everybody all together. We're just looking at the group of boys. So there are 6 total, and we want to choose 5 of them because we are already in this scenario where we want the team to be all boys. We're already eliminating the girls from the possibility. So we're just looking at those 6. How many different ways can we mix them up to have 5 on a team? And so we have toolbox, 6, choose 5, and there are 6 different ways that you can make a team that's all boys from this scenario. And again, this is 6 ways to make a team of all boys. We're not saying there's 6 boys, that's not the answer. The answer is there's 6 different ways to make a team that's all boys. We did not include the girls in the problem because it specifically said that we wanted it to be all boys. So we just only focused on the boys in this problem. Okay, if you are using a different calculator, and I didn't have these printed out to make like another, and I left my calculators in my car. It was a mess. So I just used this calculator today. But if you have questions on the other calculator, if you can't find the probability function or the probability button, just shoot me an email. But this is a great one. It's free app. It's free website. So yeah, that's it. Much better than the last video, huh? Okay. Have a good day. I will see you in the next